All right, I'm going to be doing the problem. What value of F max gives an impulse of 6.0 Newton seconds? So in this problem, we are given the graph shown here, which is a force against time graph. So we are given that the impulse is 6.0 Newton seconds, and we also know that the impulse is defined by being the area under the line of a force versus time graph. So we can use that to find our value of F max. All right, so our impulse or our change in momentum is defined by the integral of the function of time from time 1 to time 2. So we know that since the impulse is 6.0 Newton seconds, that's going to equal the area of this shape, which is a trapezoid. And the area of a trapezoid can be defined as a plus b divided by 2 times h, where a is the length of the top of the trapezoid, and b is the length of the bottom of the trapezoid, and h is the height of the trapezoid. So we know that the top of the trapezoid is going to be from 2 to 6 seconds. So that is, 2 to 6 milliseconds, which is the difference of those being 0.004 seconds. And then the bottom of the trapezoid spans all the way from 0 milliseconds to 8 milliseconds, or 0.008 seconds. And then our only unknown is going to be the height, which is F max. So we can solve for F max to be 1000 newtons. All right, and some important things to think about in this problem is just being able to use the definition of the integral as being the area under the curve to solve for a variable like force on the y-axis. So being able to also use the area formulas. In this case, that area formula is a trapezoid, is the area of a trapezoid. So just being able to identify where those different equations can be used. And then when I was doing this problem, I was struggling with the units a little bit. So just making sure you're using units used in newtons typically. So for mass, it's going to be kilograms. And then for time, it's going to be seconds. So in this case, just making sure you're changing from milliseconds to seconds is very important. And then it's important to be able to identify how the different parts of the area formula correlate to the different parts on the graph. So in our case, height was equivalent to F max, which is what we wanted to solve for.